So yes, you have come to the session that is the hardest math that will be done in elementary. And the good thing about that is that really it is a repeat of what they learned in 3rd grade of multiplication and division. But it's with fractions. And we've got to start treating fractions as they are really just numbers. They have some special qualities to them, but they behave like all the other numbers. And this is what we've been saying. This is my 5th year at this job, so you could have been coming here since 1st grade. And we're teaching strategies that work for numbers along the way. We're not teaching you one strategy for whole numbers and a different strategy for fractions and a different strategy for decimals. No, multiplication is multiplication. It's groups of. I have groups of. So let's take a look. I don't think I even gave you, fractions has its own vocabulary, but we really got started last year with numerator and denominator. And there's not much beyond that. Your kids are fine with it. Here we go. Let me try. We'll play games to see how we can get this. Is that better? I'm going to try one more thing. Okay. When it comes and goes, let me know, because remember it's to my back. So remind me when I go off the bottom of the sheet. I was just reading, there is a call her our math guru, Jo Bowler, a British woman out of Stanford University, and she's the one who has brought on all this new way of thinking that proven everybody can learn math. There is no such thing as a math brain and a non-math brain. That is a myth. We know it. We know that when you do math, there's about 5 different places of the brain that work, and they are not all on one side or one on this whole left-handed, right-handed brain, out of date. It's just not true. The connections between those 5 areas are what's important. Come on, man. You got to sit up front. We're a cozy little group, and when you need to go, you can. So it's the connections between the 5 areas. And I just read an article this morning that they took a look at brain scans, or however they do it, I think electrodes, of very, very successful people. And those 5 areas, when they're doing math, have lots and lots of connections. And people struggling have very few. So I don't know how, and the way to build up connections is like exercise. It's by doing it and doing it over. It's not by crying about it or avoiding it or pulling out a calculator. So the way we're going to get better is accepting that we can do it. It may take some of us a little bit longer than others, but we are all capable of doing it. And 2 out of the 5 areas of the brain are about visualization. Kids really push back on not drawing pictures because they're getting the message that smart mathematicians don't draw pictures, and that is absolutely false. We know 2 out of the 5 areas of the brain are about visualizing it. We have been pushing it. You've been hearing this from me for 5 years and the people before me. This is not overly new. What's new, we knew it worked. We now have the science and the research to back it up. So I gave you some of these, and the reason I didn't have them originally is that by 5th grade, we do draw a lot. We don't always. So I'm going to be really honest. If I were teaching this unit, I would have these out on the desk. I'm not sure all the teachers will, because we can draw it so easily. But I would probably be starting with these. But they may or may not, because of what their foundation for 4th grade is strong. So we're going to just jump right in. This tape diagram, again, we have been seeing it since 1st grade. It's a great visualization that helps us understand what's going on in the problem. So, there are 32 students in a class. Of the class, 3/4 of the students bring their own lunches. How many students bring their lunches? So what we know immediately is there are 32. That is our whole. Talked about this tape diagram being a part whole, and I've now learned maybe we should call it a part whole, because some kids get stuck on the idea that there can only be 2 parts. No, that's just how we define it. So we joke about that now. So how many parts would we break this into? 4. what would we do next? We're going to shade 3, or, yeah, I could shade, you know what, I'm sorry, I need to be doing this in pen. So we can shade 3, we can group 3, whatever, and we know we have 3 out of the 4. What does that tell us about the number of students? So if we've got 32 of them, we have to divide them equally into the 4 parts. 32 divided by 4 is 8. So I have 8 here, 8 here, 8 here, and 8 here. So what's the total number of students? I have 3/4. So it's 24 students. Now, I am going to be quite specific. This should say students. And somewhere this should be the ones who brought lunch. Now, we're not really, I just want them to be able to know the story. This is about students and lunch. So tomorrow when I look at this problem, if this were taken off, I should be able to read what the problem is. What else could I answer? Who don't? How many more bring lunch than don't bring lunch? There are a lot of questions that can be answered by this. That's why we have them write an answering statement to make sure they're answering the correct question. So now I have to go back. How many students bring their lunch? 24 students bring lunch. Years ago, there was an equation and an algorithm we would have taught kids what to do. It would have been 32 times 3/4. We would have said divide by the denominator and multiply by the numerator. And that's all we would have taught them. And if you forgot which way that went, you multiplied by the denominator and then divided by the numerator, don't know which one the numerator and the denominator is, you couldn't figure it out. Being able to visualize what's happening here, I can always figure it out. I may use addition and subtraction because my multiplication skills aren't good enough, which we will talk about that at the end. They need to be. Your kids need to know their facts to 100. We've moved beyond that. That's a 3rd grade standard. Most kids get it in 4th grade and 5th grade. If they don't know, majority of them, they're going to fall behind because they're using their energy trying to figure that out instead of what's going on with fractions. Okay, so 1/6 of 54. I've taken away the story, but what are we going to do? Divide by 6. So the very thing that we do physically on our bar is what they'll come to realize, oh, I divide the number by 6. So this time I only have 1. 54 divided by 6, to my knowledge, is 9. Now, by 5th grade, we don't even necessarily label all of these. We do accept that there's a pattern going on. We have dots because sometimes these get big. But I now know that 1/6 of 54 is 9. New York Rangers hockey team won 2/3 of their games last season. If they lost 21 games, how many games did they play in the entire season? Twisted some things around. So first of all, what do we know? What are we going to divide this into? 3. And now I'm going to start labeling. 2/3 is what they won. What else do I know? Well, that means they lost some. What do we know about how many did they lose? 21. These are equal places, so that has to be 21, that has to be 21, and this is 42. And here's a case where the numbers at first, I haven't thought about it because my brain has so switched to a visual model. Where would I get the answer 42 out of these numbers? Most people would have to set it down on paper to figure out what they were doing. Although as soon as you understand that 1/3 is 21, if you have 2/3, it's double. I mean, the math is definitely there, but it's not what most kids do is pick up numbers and start manipulating the numbers that are on the page. They're not being mathematicians there, they're trying to be a calculator without thinking. Abby spent 5/8 of her money and saved the rest. Good for her. If she spent $45, how much money did she have at first? May I make a suggestion? If you're working with your children, they tend to draw their tape diagrams too small. Actually, it's either or. they draw them quite small, or they take up the whole page and they can't add anything else. You got to be able to see the work. And that's just a practical suggestion. If they need a separate piece of paper, by all means, get a separate piece of paper. Well, how many is this going to be divided into? Now, you saw how quickly I did that. I do not have a ruler. I'm not measuring. But I am trying to make it reasonably accurate. I know that if I'm dividing, the groups are supposed to be basically equal. That is perfectly good enough. But we do not want, make sure where I want to write this. We don't want something like this. 1, 2, 3, 4, 5, 6, 7. I mean, we need some sort of time. And they talk about in that class, especially 8's is easy. You divide it in half, and you divide those two in half, and then you divide those. And you know, fifths are harder, but you scoot it over from the half. And our kids are capable and should be held accountable to being that reasonable. Okay, we have 5/8. So this is how much she spent. And this equals 45. Dollars, reals, obviously it doesn't matter. So what does that tell us about each one of these? Yeah, so we're getting down to the unit, the value of each unit. So I divided that 45 by the 5 places.
It's 9.
It's 9. Thank you. There's my morning. Okay. So, how much money did she have left? Each one of these are 9. This is what she has left. So she has So one of the questions we get a lot from parents is how do kids communicate their reasoning? I can see very quickly not only what I did right, but what I did wrong, and what I had to rethink about, or help get somebody to help me to rethink about what I did. This reasoning was communicated quite thoroughly, but I do have to put in the labels, and I do write that answer statement. Okay, Joachim is icing 30 cupcakes. Spreads mint icing on 1/5 of the cupcakes and chocolate on 1/2 of the remaining cupcakes. The rest will get vanilla icing. How many cupcakes have vanilla icing? How many of you would just like to walk out of the room right now instead of solving this one? This is one of those ones that right off the bat, it's like, wait a minute, I've got fifths and halves, and am I going to have to find common denominators? I think I remember that term. Or we could make it visual. So what do we know? We know there's 30 for a total. Oops, I'm going to start with 1/5. And 1/5 of it is mint. I also know that that's 6. easy, and this was the way it was written. 1/2 of the remaining cupcakes. That remaining is a big word. So that's actually easy because I've got 4 parts, so half of them are going to be, let me get my flavors right, chocolate. The rest would be vanilla. And how many? Well, each unit was 6. So there will be 12 vanilla cakes. So this is dividing, this is what we call set. We're starting with a number and we're trying to find out what's within the sets. I'm going to be honest with you, the kids don't have much trouble with this one. But they will be, and this is a very real life thing that happens. You know, who brings lunch, who doesn't bring lunch, the flavors. And I'm not sure, maybe that's why the kids have less problem with it, because the application is pretty straightforward and they hear it and see it. They're doing this in 1st and 2nd grade when they talk about things, but they're not doing it mathematically, they're just figuring it out. They aren't, they're hearing it. It's in their real world. So now we're going to move on to the multiplication of fractions by each other. And I want to get into the language. This problem here is I have 2 groups of 3. Do you agree with that? This is how we started back in August of this year in 3rd grade. And the language we use is 2 groups of 3. And then we started writing 2 groups of 3 while these were sitting here. And then we moved on to 2 times 3. But we know how to read it now. I have 2 groups of 3. Okay? So if we keep that language, there is 2/4 of a chocolate bar left on the table. Jose came in from playing and ate 1/2 of it. First of all, how do I put that in the language? It's not in order of the way the story tells me. I have to think about it. In this case, I have 1/2 of 2/4. Now I could say I have 1/2 group of 2/4, but we don't need to, so we tend to drop the language. So I have 1/2 of 2/4. Does that make sense? Okay, I'm going to ask you to pull out 2 colored pencils, and I swear this is the hardest part. Please get 2 colors that are very different from each other. Instead of light blue and light green. Those are not 2 good ones. Do light blue and pink. Oh, those are the colors I have. We are doing the area model, which they learned how to do, again, back in 3rd grade and was very reinforced in 4th grade. In area, we haven't reinforced area as in the area, well, we did in 3rd grade. The area of the rug is always length times width, or width times length. It doesn't matter. But that's why we are drawing some things vertically and some things horizontally. There are other models, but the area model works forever, including algebra. 2x plus the quantity 2x plus y times the quantity 3y minus 2 will still work with this same model. So that's why we stick with this model. There are other ways. We could do groups of drawing little things, but we are sticking to what we know and what we've already proven. Okay, so I'm going to start off with, what do I have? I have 2/4. I'm going to shade it. That's how much of a candy bar I have. I think most teachers are going to ask them to start vertically first and go horizontal. It doesn't matter, but it just becomes something that as we're walking around the classroom, we know they're grasping it if they're all doing it the same way. If a child really sees it the other way, they're going to be allowed to do that, but most won't. Okay, so now I have 1/2 of this. Well, if I draw 1/2 across here, and I draw it across the whole thing, so I'm going to have 1/2 of it. But how much do I eat of that 1/2? I eat that much. Can you see that I ate 1/2 of that piece. To begin with, you might even look, I had 4 little pieces, I ate 2 of them. Is that 1/2? Okay, and I'm going to be real honest here. There are 2 different methods. Some color in the 1/2 all the way apart, and but we're always talking about the lap over. It doesn't change the mathematics. It's really how some kids see it. Some of them want only the half of the part they really have, or the others see it the half of the other total. Yeah, it's really,
It's okay.
it's okay, absolutely. Either one of these is okay. And students will have a real preference. And both of them give you the right answer. That's what I'm saying. So you may see it 2 different ways, but you will always see this area with the overlap. Now the importance of drawing the halves and quarters is I now know that I have 2 pieces out of how many? 8. And that is the proper answer. I was going to collect answers here. Move this over. Real high tech with a whiteboard. I'm not sure I'm going to be able to erase this. Hello, come in. So this was 1/2 of 2/4, and we proved that it equals 2/8, right? Okay. So what if we have 1/2 of 1/3? So I'm reading it. I'm not saying it as an equation. So I have 1/3. I'm going to start with my thirds. And this time, just to be ornery, I'm going to shade the one in the middle. Because it doesn't matter. The importance is that I have 1/3. And it says I have 1/2 of it. How much is shaded with both colors? Where is the overlap? Did anybody draw it on the left, shaded on the left or the right? Did you get 1/6 also? If you shaded the top instead of the bottom, would you get 1/6 also? So I'm going to collect this one. This was 1/2 of 1/3. Okay. 1/3 of 3/4. Go ahead and do that, and then I want you to compare it with your partners. Get the same answer as somebody at your table. Here's my area. I count how many overlap, which is 3 out of how many? Which is 12.
I can't see when you are, I can see when you're doing it in lines, but I can't see when you are marking. You know, I'm sorry, I split the square in 4, and then I see that I have 3.
So you have 3/4.
But then I just take the
So
1/3.
because we're
But I
using the
can't
area
see.
model,
Yeah.
you have, is length times width. So if we do the
Okay.
fourths vertically, we have to do the thirds horizontally.
That's what my son had questioned. Why do you have to put
Yeah,
it
because it's the area model. We can do it other ways, but how we find area, which is a rule, it's length times width. One goes this way, one goes that way.
Because I'm like, where's the 1/3? I don't see it, but now I see it because it's horizontal.
So let me show you what this one would look like before they overlap.
Okay.
I'm gonna try to get my colors correct. I did 1/3 this way,
That's why, that's what lost me.
and I did 1/4. Oh, what, it was 3/4, I believe?
3/4.
Yeah.
Okay.
And then you put them over the top. But what we really want, and we show them this, and they may even end up with these really cool overhead tiles that they can put on top of each other. The problem is that becomes a little bit formulaic. Do they understand what they're doing when they do this? And I really think the language here is I have the 3/4, and I want 1/3 of it. Or, yeah. So I have to break them into thirds. And that's what we talk a lot about. Now, mind you, this is a 7-week unit, and you're getting it for 50 minutes. So we're going to do this a lot. But that horizontal versus vertical is because the model we're using is the area model, and that is length times width. We did it in 3rd grade, or 4th grade with 34 times 28, and we filled in all the blocks. This time, we don't get all the blocks, we just get some of them, because it's a fraction that's less than whole. Does that make sense? I'm going to show you other ways, but they're problematic because if kids just take 3/4 and divide each one into thirds, they're not going to keep doing it to everything and they lose the denominator. What this one does so beautifully is show you how many little pieces there are. How many little pieces did they have to begin with? How many pieces did they get in the end?
So how would you know if, to go vertical or horizontal, do you go by the first number, or it all depends, or?
Can I hold off? I will answer that.
Okay,
I'll give you the short answer. It doesn't matter.
all right,
It matters at the very beginning when we're talking about a story,
okay.
and it all depends on how the story is written. Usually, I vertically put the things that I have, and whatever I'm taking the group up, I put horizontally. You get the same answer, and we'll talk about that in a minute. Okay?
Thank you.
Yep.
I don't get this one. Why not three or four?
This one that we're talking about. Let me draw it slower because I put it up there. It's 1/3 of 3/4. So let's say I have my 3/4, right? If I'm going to take 1/3 of it, I have to divide them into thirds. But I only get 1/3 of this. So this is where it's harder when you don't have a story. People kind of groan when they see word problems, but actually word problems give us context, which actually makes it easier to talk about. So I don't think so. I think they're starting next week. I have to book this room so far in advance that I kind of look at the calendar and when I can get it. So I was going to mention that.
That we learn before this.
Yeah, and sometimes I try to do it within the first week, and it all depends on the calendar. Now, I will ask that you not go home and try to pre-teach this, because they're going to do hands-on things, they're going to take it slower, and I am not going through this step by step like they will get it. And I'm going to really ask you not to do what I'm doing up here on the board. So that was 1/3 of 3/4, was that the problem?
Yes.
And what answer did we get? because mathematically the correct symbol is multiplication. In my head, I'm probably still saying of, because that really helps me understand it. It's perfectly fine. But I need to know how to write it as a mathematician. I have my 2 bits. I have 2/3 of it. You see, I'm the one who likes to draw the whole 2/3. I understand where some people only like to shade in what they actually have, but we get the same answer. And what part of that whole is 2/3 of, read it right, 2/3 times 2/5. What is the answer? Okay, I'm looking at the clock. Do we need to do this last one?
No.
Okay, but I do want to bring it back to what it sounds like in real life. Santino bought a 3/4 pound bag of chocolate chips. He used 2/3 of the bag while baking. How many pounds of chocolate chips did he use while baking? So this is which one comes first. I always do what he has. So to me, I would shade in 3/4. And I always do that number vertically. How much did he use? 2/3. So I personally would write 2/3 times 3/4. We'll have a discussion on that in just a second. Now, being a word problem, I would want this. This is chocolate chips. This is used. I doubt that they're going to ask them because really this isn't much of a problem solving. It's just more context. This model can be used for mixed numbers like 1.5 times 3/4, but not until we understand this and we can make this work. So does this work for you? I want you to now know that we are not sending your children on always drawing pictures. We do move past it. So I've collected all the work. Let me see, turning this back on. These are the answers. Oh, there's the on button. So these are what we've collected. That's all the work on your paper. What do you notice?
If you multiply two fractions, it's numerator into denominator, but denominator.
Did it work every single time? Does it make a difference if I switch the order around? Did it make a difference? Yeah, but I may have just picked one that doesn't work. Let's see another one. Whoops, that's the answer. So we have a big discussion, and this is where I don't stand up here and tell them to multiply, you multiply numerator by numerator, denominator, denominator. I have the kids figure it out. That's what we call them making up their own rules. Is it the same rule I know works? Yeah. And I arrange it really carefully, and I collect this data over several days. But now they know why it works. It wasn't just me telling them so. And also, if they ever get stuck and can't remember, they can go back to the picture, figure it out, and then go, okay, I was right. There's a big security in understanding go why. In 5th grade, they should walk away knowing how to multiply fractions at a fluent level. They should get to this. And I'm talking fractions, not mixed numbers.
But in the story setting, it helps to understand that what was first and what was of what.
Yeah. But once you get to this understanding, I probably out of habit would write it down the way the story goes, but if I didn't, I also know I'll get the same answer.
Because then they're confused, like what should be made first? Like,
Yeah. I agree.
bonding.
What will happen when they become fluent and completely understanding it, which means they can do it with ease, it just doesn't matter. And so that's that 3 times 4 equals 12 and 4 times 3 equals 12. But that is a very different picture. And that's where we want to get away from flashcards and that memorization, is we need to have them to be able to visualize it.
And in 6th grade, do they still model? Or they have to do the equation?
Not at this level. I mean, to reinforce what they've maybe lost over the summer, yes, but they would model it for a day just to get to this. So this is 5th grade multiplication. They should become fluent in. The division we're going to do is not to fluency, it's an introduction. So this is the fluency, but not division. Let's move to the next page. Sorry, I'm still getting over my cold, but if you're going to get a cold, you should get the one I had because it didn't wipe me out at all. It was actually fairly painless, but. Okay, division of fractions. There's 2 different ways. Are we dividing the fraction, or are we dividing a whole number by a fraction? You've got to be able to picture the difference because that's a very different answer. So we're going to do with 1/4 divided by 3. And I'm going to be honest here, this is so much easier to do on paper than with manipulatives, so we are going to do that. Manipulatives are to help us. They are not a rule that we have to follow. So if I have 1/4, I'm going to divide my tape diagram into fourths. This is the 1/4 that I want. Can I divide my 1/4 into 3 groups? Sure. But if I do that to one of my units, I have to do it to all. That is the big part of this question. So, what is the value of one of these pieces? I'm dividing it into 3 groups. I want to know the size. It equals 1/12. So I'm wanting to know the size of the piece after I divided my 1/4 into 3 pieces. So I can tell you where the mix-ups are. They'll go back and they'll say, oh, it's 3/12. No, that's what 1/4 equals. I want to divide that 1/4 into 3 parts, so I want to know what the 1 piece is. That makes sense? So 1/3 divided by 2. How can we divide 1/3 into 2 groups? 2 groups, okay, I can do that. Have to do it to everything. Here's my original 1/3. I now have 2 groups. What is the size of each of those groups? 1/6. I think maybe that's a sense to what is the size each of the 2 groups. front of you? Okay. Sybil has half of a pizza left over. She wants to share the leftover pizza with 3 of her friends. What fraction of the original pizza will Sybil and her 3 friends each receive? What's the very first thing we're going to do? Yep, you got half a pizza. Who's she sharing it with?
3
3 friends and herself. That is one of the most common mistakes. So, pretend those were equal. They're fairly equal. But if I did it to this half, to be able to, oh, that's terrible. It's better when I got the last one in. So I'm dividing 1/2 into 4 groups. You see my 1/2? I have my 4 groups. What is the size of each of those groups? At this point, we can see there's some numbers there. I can see relationships. And then I would give them, right now, it looks like you can, I don't even know what they'd say you're supposed to do. What we would do is put those same problems up there and find out that there is not a pattern to how they get their answers. So division, like multiplication, has an order it has to go in, and it doesn't work the same way as multiplication. In 5th grade, they don't need to know that. I'm sorry, not that they don't need to know. We stay at the visual point. We do not develop the algorithm. So we have the fractions divided into parts. We also have a whole number divided by groups of 1/2. And here's where we run into that just because you divide, the answer does not get smaller. We do a really good job in 3rd and 4th grades of not using that language, but you guys may not be used to it. It used to be in the old days that when you multiplied, you got a bigger answer, and you divided, you got a smaller answer. That is only true of whole numbers, not of fractions and decimals, so we don't use that language anymore. And it makes sense when you take something this obvious. We have 4. I want to divide it into groups of 1/2. So my question is, how many 1/2s are there in 4? Oh, I can draw that. Now, this is very careful. You see these are whole or solid lines? That means I have 4 of them. This is not fourths. So, I can divide each one of my wholes into groups of 1/2. Here's 1, here's 1/2, and 1/2. Here's piece number 2, here's 1/2, here's 1/2. So when I divided 4 into groups of 1/2s, I get 8. We will have to do that over and over again to get the kids, even though it's never been taught to them that it should be smaller, it still kind of rocks their world. I am using whole numbers here. They don't have to be, but I would be very careful about the whole numbers because we are not getting to a fluent point where they can handle any of this. And there are numbers that are much, much trickier, and that's for 6th and 7th grade. We are just doing that foundation that you can draw it and you can figure it out. So I have 5 groups, 5 divided by 1/3. What does that mean in words? I want to know how many groups of 1/3 there are in 5. So if I figure out how many groups of 1/3 there are in 1, which is 3, I can then multiply it by 5 and get 15. And that is where your invert and multiply comes from. But nobody ever knew why. And I honestly couldn't remember whether that was multiplication or division, so I would always solve it both ways because I knew the right answer. Then I would apply the algorithm. That is not what we want from our mathematicians. I mean, it's pretty good that I had a strategy to figure it out, but I didn't understand what was going on. Where this, I can completely see it. Oh, I've got 3 here. I have 3 groups of 1/3. And I'm going to have it 5 times, so I'm going to have 15 groups of 1/3. Now I can find all sorts of ways of figuring this out when I can visualize what's going on. And to begin with, you better believe I'm going to be doing this. Okay, I have my 5. Divided each one into groups of 1/3, and I have 3, 6, 9, 12. Could this be done on a number line? Absolutely. So to put it into context, Mrs. Silverstein bought 3 mini cakes for a birthday party. She cuts each cake into quarters and plans to serve each guest 1/4 of a cake. How many guests can she serve with all her cakes? Well, now I know if I'm breaking one of my cakes into fourths, and I have 3 of them, I'm going to get 12, and I can prove it. Now, if a child drew 3 round cakes and did the same thing, that's fine. But we do get them somewhat into just using that same tape diagram over and over. We don't care which way they do it. And again, the number line would work just as well. You go from 0, 1, 2, 3. I broke them into quarters. How many quarters did I have? I could count them up. I personally, and I don't know how kids feel about it, I don't think this one, it leads to a perfectly good answer, but to me it's not about pieces. And that's why I like this, I personally like this one better, because I feel like I have pieces. If a child sees it one way or the other, that's great. That is the heart of this unit. And the real big thing is I can remember teaching this unit 6-8 years ago. We taught the multiplication, we taught the division, the test came and they didn't know which to do when. We had pulled the numbers out without giving the context. There's a lot of talk about how many word problems they do, how wordy it is. It's like, yes, because that's when they're going to understand what the math is asking them. We do not, I repeat all my same jokes. We do not walk into grocery stores and have somebody ask me 3 times 4. We buy a can of something that costs 12 reals, and I want 3 of them, and therefore I have to multiply them. You have to understand the context. So as I mentioned earlier, I also want to talk about, see, I always get to go 2 minutes over. We have some answers, 2 8s, 3 12s, 6 12s. All of them can be simplified. Mathematically, those answers are correct. And the more that they're in context, sometimes they ought to be left that way. The flip side, in algebra, they need to know how to simplify things. So, the real answer is, if the teacher asks them to simplify, which they know how to do, they have to simplify. On an assessment, if it doesn't have anything like that, these answers would be correct. But as soon as they ask you to simplify, because we need to know that they know that skill, because that's used in algebra. They'll have to do that a lot. So it's not the automatic, dogmatic that it used to be, but it's still a skill they need. And we could go back to these pictures and find, let me pick an easy one. Do I have a third color? I think I can do it here. 3 12ths does simplify to 1/4. Can I see it? Here's 1, and that's the one I have. Here's a second, third, and fourth piece. So can you see that 1 out of my 4 are highlighted? Oh, yes, I can. So we can show it to them. It's not a big part of this unit, that understanding of groups of, and what you're looking for is the big understanding of this unit. Being able to go back and forth. Once they've learned multiplication and division, do they understand the difference? On the very last page is my typical page of, if your child is bored and doing something, I want to highlight when they go to math playground, there's 1,002,000 things to do. Steer towards the logic games. They're fabulous. Bedtime math might look childish. Keep going, there's stuff in there for it, but it's stuff that you can talk about with your kids. Bedtime math says, if you're willing to read a book every night to your child, why aren't you willing to talk about math every night? They give you interesting things to talk about. We do not want flashcards. Math cats who do math, they're fine. These 3 are just fine. They were things I was trying just to give you different ideas. Dreambox, again, is a paid one. There are kids that just love it. It's a game that they get started and they can just play it on and on. Code.org is, as it sounds, it's about coding. So it's a different direction. It's mathematics. I meant to double check whether we still have a school account. I don't quite know, I'll be honest. Common Sense Media is what you should be using for everything your child tries to say, eat, and do. It tells you about books, videos, games, all of this, at what age they're appropriate developmentally. Do you want your kids seeing ads on their games that they're playing? And in 5th grade, they're kind of on a crux there. They are old enough to know the difference that this is an advertisement being set up, but it talks about maturity levels. I will argue till I die that Little Women should not be read in 5th grade. I don't care how well your child reads, it's a love story. They don't know about love in that sense. So, they give those types of guidelines. The last thing that I mentioned, if your children do not know their multiplication facts easily, they need to. It's time. And I get stuck on 8 times 7 and 8 times 8. I have to stop. 2. I know all the rest of them, and I'm pretty fast, and I have a strategy to get there. They should be not having to, if we call it, they don't have to work to get those numbers. These are fun games. I can open them up to see if the link is still working, and 10 minutes later, I'm still finding myself playing the game. So that is that great way of learning, where it's not a chore, where if they make a mistake, it's not embarrassing, they just keep, and the game will know to keep throwing that one back at me. So the repetition. I really appreciate you guys showing up today. And I can't really ask you, we have a sneaking suspicion it's a Tanine thing and getting the word out. But you're the ones who figured it out. If you want to talk to your friends, we are not going to go back to the old way, so they need to figure out the Tanine. And we need to hear what's working about it and what's not. Because I've heard some of the ways it's an awful lot of clicks.
Yes.
But I think when you receive an email saying this is up, people acknowledge it more efficiently than going on the PT and searching. Opening the app.
I have been told I absolutely cannot do that, because then we're really teaching you don't really need to go to Tanine.
That's what happened with me. So now I'm purposely going on to find out what's happening.
To be fair, Tanine came a lot about because parents were complaining about the number of emails. And I guarantee every single one of us that sends you an email thinks ours are important. So you guys think mine about this is important, where another parent's like, quit sending these to me. So they're trying to strike that balance. It's the first year. I think there will be some adjustments. I don't even receive it, so I don't know what it looks like. I thought that the original email you get sends you to a page where all the latest things are there. So you really shouldn't be having to click, click, click unless you've gotten late. But I'm pretty sure.
No, so when you get a new notification in your email, then you open to the
And then
you have the page where it says the updates.
Okay.
Announcements.
Yes.
Okay.
Yes.
And there you can mark
Well,
your,
part of this might just be welcome to the life of.
just a good time, like, just
Yeah,
not-
it's an adjustment of thinking.